Here in Circle G, we are going to solve x and y, looking into the perspective on what are they representing, and at the same time, the figures that are actually related to the entire circle. So x here, we have 4 x's, but they have the same measurement. It's just that we just need to substitute whatever value of x here to get the length of this, and this one and this one as well. By the way, this measurement is for this given segment here. Nevertheless, x stands for the measurement of a segment. Y is also a measurement of a segment. But more importantly, these are actually segments that are results from intersecting chords. In this case, we are going to use the chord-chord power theorem here. But since there are 3 different chords, let us try to solve first 2 chords here where we could solve the value for x first. As to why we start with x, we cannot solve y here because only one of the 6 segments here is exact. The others are represented by variables or has expressions involving variables. I'm talking about this segment here, this segment, and this segment, or that entire chord with x and x plus 1 at this side, and this also this chord as well. So let us have this given figure cut out from that. So we have this, and then we are going to use the chord-chord power theorem in order for us to solve the unknown measurement of x. Let me do this again here so that we have enough space in solving later. So the chord-chord power theorem tells us that if 2 chords intersect inside the circle, the segments or the portions of that chord that is cut by the point of intersection for one chord and its product is equal to the product of the segments of the other chord as well. That would mean we have here x minus 3 times x plus 5, the segments of this chord. The result for this, or the product, must be equal to the product of x here and x plus 1. This is the chord-chord power theorem. And with this equation, we can use this to solve the remaining unknown measurements. So here, using the FOIL method, you'll have x squared. You will have plus 5x here, but minus 3x and minus 15 is equal to, using distributive property, you'll have x squared plus x. So here you will have a quadratic trinomial, x squared plus 2x minus 15 equals to x squared plus x. Now it seems like you have here quadratic expression, but notice the presence of x squared on both sides, to which you can just simply cancel out because it will just be equal to 0 whenever we move this to the other side. So we are left with 2x minus 15 is equal to x on the other side. And then we manipulate this given expression in order for us to solve for x. So you will have here 2x. By transposing x to this side, you will have minus x. And here, the negative 15 becomes 15. And finally, the value for x, as 2x minus x is just x, equal to 15. And since there is a side, you will have here 15 units. This is the value of x for the given circle G. This would mean this is 15. The other side, plus 1, you will get here 16. This plus 5, you have here 20, and you have 15 minus 3, you will have here 12. So pardon if the figure is not accurate in its illustration, but I'm just showing you this one to prove that the product of the measurements of the segments of the chord is just equal to it's the product of the other. Because if we're going to multiply 12 times 20 here, that's 240. If you have 15 times 16, you will also get 240, because that becomes 30 times 8, 240. This is the correct value for x. We are going to use this to solve for y, since x is already given. Now it's up to you which measurements you are going to use, whether you would like to use this measurement or that measurement, because it also follows chord-chord power theorem. Just for the purpose of solving y, let us use this second figure, where I chose the value of x and x plus 1. In short, this is again given to us as 15. You could automatically erase this one. And you could also erase this or remove this, since it is already given as 16, so that there would be no more confusion. Okay? So now that we have the exact value for this measurement, and as well as for its other segment that is part of the chord, originally part of the chord, let us try to use the chord-chord power theorem in solving for the value of y. And that would mean the product of this segment and that, so you'll have 8 times y, or 8y, is equal to 16 times 15. So you will have 8y is equal to 240. Okay? And then when you divide both sides by 8, you will get a result of y, which is just equal to 30 units. This is the result for y in this given circle G. So you already have solved for x, and now you have y. This ends the problem.